Hello guys, this is Rakesh from Bodhee Prep, and in this video we'll be understanding the building blocks of algebra, and the topic is understanding algebraic expressions, because this is the very important topic, very easy to understand of course, but this is widely used in algebra. Each and every term we need to understand clearly, and we need to distinguish between those meaning of those terms, right? So let's start the process of understanding algebraic expressions. So I'm writing an example. With the help of example, I'll dissect it and I'll make you understand the parts of algebraic expression. Then you will understand the clear meaning of what algebraic expression means. So I'm writing an expression that is 4x plus 7, right? This is an expression which is formed by combination of variables and constants, right? So anything which is formed by combination of variable and constants, they are called algebraic expressions, right? Here, x is a variable, right? 7 is a constant. 4 is also constant, but 4 is multiplied with a variable. So in the previous class, or in fact, I don't know. So 4 is also constant, but this constant is actually getting multiplied with the variable. So we call this as coefficient. We call this as coefficient, right? And there is a plus sign. That means there is some mathematical operator also involved, right? The basic mathematical operators are what? Plus, minus, multiplication, and division. So their combination, variable, coefficient, constant, mathematical operators, their combination of these things together, whatever is found, we call it as algebraic expressions, right? So this is a simple meaning of algebraic expressions. Now again, if I further want to dissect, so let me write few more algebraic expression to tell you what is the meaning, exact meaning of algebraic expression. So I'm writing an exception which is x square, 2y square, right? 3x square minus 5, then 4xy plus 7. All are algebraic expressions, right? This is an algebraic expression wherein we have used only variables, right? So it is not necessary that the constant need to be there. Only variable itself can be a part of algebraic expression or can be called as algebraic expression. This has a variable y, mathematical operator square, and a constant which is multiplied with y square. This constant, we name it differently, we call it coefficient, right? Here again, we have a variable x, mathematical operator like this, the constant 5, the coefficient 3. Here we have two variables. We have variable x and y, the coefficient 4, and the constant 7, and a mathematical operator 4. So all are algebraic expression, as you can see, right? So algebraic expression not only have a variable and a constant, it can have a variable with another variable also. For example, here there are two different kinds of variable. One is x and one is y, right? So their combination is called the algebraic expression. So I hope I have given enough time for understanding the algebraic expression. Now let us further dissect it. So if I write any algebraic expression, for example, 3x square plus 7y, this is also an algebraic expression, right? Here we can see that this algebraic expression is formed by the combination of 3x square and 7y with a mathematical operator plus or the addition. Each of these are called terms, right? So this algebraic expression has two terms. One is 3x square, another is 7y, and they are added, right? So algebraic expression, if I have more than one term, usually they are added, correct? Each of these things are called terms. And if I look at each of these terms, that is the first term, 3x square, this further is nothing but 3 multiplied with x multiplied with another x. So each of these number, that is 3 and the variable x, they are factors of 3x square, right? Because each one of this will divide 3x square for sure. They are formed by that. So they are factors of 3x square. Similarly, 7y as a term has a factor 7 and y, correct? So if I summarize whatever I have done till now by taking an example, say 4x square minus 3xy, this is called expression, algebraic expressions, right? they are formed by addition of 4x square and minus 3xy, I can say, right? Each of these are called terms. Further, each term has factor. For example, this term has a factor 4, x and x. This term has a factor minus 3, x and y. So they are called factors. So I've just drawn a tree to explain you how expressions are formed, right? Fair enough. So this is sufficient enough to understand what is algebraic expression. Now let's move to the next important thing, which is what are like terms and unlike terms. So I'm writing a very simple equation, algebraic expression. Using that, I'll explain it. So if I have an expression 2xy minus 3x plus of 5xy minus of 4. This is an algebraic expression having the term 2xy. Each term has factor. For example, this term has a factor 2x and y. This is another term. This is another term. This is another term. Constant itself can be an algebraic expression, we can say, right? Without variable also. So if I look at these four terms, I see that these two terms, if I ignore the coefficient, then their variables are same, right? 2xy and 5xy. In terms of factors, they are factors 2x and y. These are the factors of this term. This term has a factor 5x and y. Barring the constant terms, if I ignore this, then we can see that the variable factors are same. So in this case, variable factors are same. If such thing happens that the variable factors are same, then we call those terms as like terms. And if they are like terms, we can easily add or multiply or take this subtraction, whatever the mathematical operation given between them, we can do that. For example, here, if I collect them together, we can say that xy and xy is common. It is plus 5 and here it is plus 2. So together these two will become 7xy. 2 plus 5 will make it 7 and x and y will remain same. Minus of 3x plus, sorry, minus of 4. So we can further simplify this and write it as 7xy minus 3x minus 4. So this is all about like terms. Of course, if this is the like term, then what is the definition of unlike terms? Whenever the variable factors are not same, then they are unlike terms. For example, comparing 3x and 2xy, they are unlike terms. Why? Because their variable factors are not same. I hope you have understood the meaning of like terms and unlike terms, right? Now let's move further and try to figure out what is the value of expression. Value of expression, meaning of this term, value of expression. If I write any expression, say I'm writing an expression, say x plus 4. This is also an expression. I want to find the value of this expression when the variable takes certain value. In this case, suppose the value of x is 2. So what we need to do is that we have to replace the variable with the required value. So I can replace x with 2 and take the constant as it is. I'll be getting the value as 6. So this becomes the value of this expression when the variable value is 2. Or we can say that the value of expression is 6 for x is equal to 2. Correct? So find the value of expression for x is equal to 2. I'm just giving few examples. Say 4x minus 3 and say 19 minus 5 of x square. Just pause the video and do it. You will not be taking more than a minute. Okay, I hope you must have done it and you'll be getting the right answer, I'm sure. How? You have to just replace the variable by its value, which is given in the question. So in the question, let's say that take the value of x as 2. So we'll just replace wherever the x with 2. So I'll be getting it as how much? This will be 8 minus 5, which is, sorry, 8 minus 3, which makes it 5. So 5 is the value of the expression. Here, it will be 19 minus 5 into 2 square, which will be 19 minus 20, which will be equal to what? Minus 1. So minus 1 is the value of the expression for x is equal to 2. So this expression, the term value of the expression is also understood. I'm making you comfortable with the phrases, terms used in algebra. These are very, very important because once you understand this meaning of this, then definitely you can understand the context of the question. And once you have understood the context of the question, then definitely you can apply the relevant concept to solve So to solve that particular question, right? Okay, let's move further. So the next thing is polynomials. Next thing we have to understand is polynomials. So what is polynomials? Polynomials are a kind of algebraic expression wherein it has only one variable, right? Polynomials are algebraic expression wherein it has only one variable. For example, x cube minus x square plus 4x plus 5. This is a example of polynomial which has only one kind of variable, and that variable is what? X, right? Of course, that there are three terms having x with different powers, right? But one thing is sure that all have the power of x in each of this is non-negative integer. This is very, very important. The power of the variable should always be non-negative integer, then only we will call that particular expression as polynomials. And of course, that polynomials must have single variable, right? So here we can see that the power of x is 3, the power of x is 2, the power of x is 1. Here there is no power of x. Technically, I want to manipulate it by writing here x. But obviously the value was 5, so I can write it as x to the power 0. Because anything power 0 is 1, we know, right? So whether I write it x to the power 0 or completely ignore this, it will not make any changes in the value of this polynomial, right? And if you look at the powers, they are all non-negative integers, correct? So this is an example of polynomial. Now, if I take another polynomial, which is x plus 1 by x, or another algebraic expression, I would say, we have to test whether this is a polynomial or not. If you write them in power of x, then this is nothing but x to the power 1 plus this 1 by x can be written as x to the power minus 1. Now, this is not a polynomial. Why? The power has to be non-negative integer. This thing is for the power. The power has to be non-negative integer. Here, one of the power is negative. So obviously, we will not be calling this expression, this algebra. This is an algebraic expression for sure, but this is not be considered as polynomial, right? Similarly, under root of x plus 3. This is also not a polynomial. Why? Because this can be written as x to the power 1 by 2 plus of 3. Again, the power is not an integer. It's a fraction. So obviously, this is again not a polynomial. I hope you have understood what is polynomial now, right? If the polynomial have different powers, what does it mean? Or what do we call? Can we categorize it? For example, let us take this only. Here, the highest power of the variable x is equal to what? 3. So we call the highest power of the variable for any polynomial as degree. We call it as degree. So this is a polynomial with degree 3 because the highest power of the variable x in this case is 3. Similarly, x to the power 5 plus 4x plus 7. This is also a polynomial. What is the degree? The degree is 5 because the highest power is 5. Right? So you have understood the meaning of degree also, I believe, right? So there are small definition of many terms. So I'm just touching them so that you should be remembering them whenever they appear, right? Now, usually what happens is that polynomials usually have many terms. So in mathematics, if we are working with the polynomials and every time I have to keep on writing all those terms again and again, it becomes cumbersome. So what we do is that we come up with some notation to notate that particular polynomial so that the repetition of each term or every time the repetition of writing of the polynomial should be avoided, right? Something like what happens is that we have some name, real name, which is maybe a very long, but in our home, we have our pet names, right? So pet name is nothing but a substitution of our original name. Similarly, in polynomial, because they are at times they become cumbersome to write again and again, we denote them with some number or with some notation, right? For example, the same polynomial x cube plus x square plus 4x plus 5. This is one of the polynomial. I may call it as p of x. I read it as p of x. So whenever I have defined this here, whenever I'm writing p of x, after definition of this will denote this entire expression or polynomial, right? So it's not necessary that p of x is the only way of denoting it. We can have q of x, we can have r of x, anything. But a simple notation of p of x or q of x usually is taken to denote any polynomial, right? This is all about polynomial. Now, the most important thing is zeros of polynomial. This is very, very important. What is zeros of polynomial? I'm writing a polynomial, say x square minus 2 of x plus 1. This is one of the polynomial. Let us denote it by p of x, right? I want the value of this polynomial when x is equal to 0, when x is equal to 1, when x is equal to minus 1, when x is equal to 2. I want the value of the polynomial. So how do we find the value of the algebraic expression? We just substitute the value of x with the given value, with the given value itself, right? So let us take this. So this simply means that instead of x, we have to take 0. So instead of x, we have to take 0. So this will be 0 square minus 2 into 0 plus of 1, which comes out to be 1. Right? So this becomes the value of this polynomial for the value of x is equal to 0. Similarly, for 1, we'll be having 1 square minus 2 into 1 plus 1, which becomes equal to what? 0. This is very important, interesting. Next, p of minus 1 whole square minus of 2 into minus of 1 plus of 1. This will become 1. This is minus 2 plus of 1 will make it 4. Similarly, p of 2 will make it 2 square minus 2 into 2 plus of 1. So again, it comes out to be 1. Barring this, you can see that we are getting different values. Here, we are getting the value to be 0. This is very, very interesting. Why so? Because the value of x is equal to 1 is reducing the entire polynomial to become 0. So x is equal to 1 is called 0 of the polynomial. So for any polynomial, a specific value or values of x for which the value of the polynomial becomes 0, we call that value of x as zeros of polynomial, right? There is another name of zeros of polynomial, which is root. So whether you call it zeros of the polynomial or you call the root of the polynomial, both have the same meaning. So from now onwards, rather than calling zeros of the polynomial, we will be calling it root, right? So if I have a polynomial, say q of x, which is equal to x plus 2. So just by simple observation, I can say that x is equal to minus 2 is a value for which q of x becomes 0. You can test yourself. Put the value of x is equal to minus 2 here. You'll be getting q of x to be equal to 0. So x is equal to minus 2 becomes the root of this polynomial. So what is the root of the polynomial? The value of x for which the polynomial become 0. Right? So can we do the other way around? Other way around in the sense, can we find the roots by equating the polynomial to 0? For example, x square minus 3x plus 2. This is a polynomial. I want the roots of this polynomial. So, should I equate this with 0? Yes, we can do so. We can do so. What we have to do is that we have to identify those values of x for which this LHS portion becomes equal to 0, right? For the time being, what I'll do here is that I'll not be taking a polynomial with a higher degree. I'll be taking a polynomial with a single degree, right? We'll come on to these kind of polynomial also. This is called quadratic equation. We'll be dealing it at length later on, right? If you want to find without using the actual formula and the other techniques, what we can do is that we can start with initial few values of x. It's clear that x is equal to 0 is not making this expression 0. For x is equal to 1, you can see that this expression is becoming 0. For x is equal to 2, I think the expression is again becoming 0. So these are the two roots of the expression, or we call roots of this quadratic equation, right? Remember this term, root of the quadratic equation. This will be heavily used in the upcoming lectures or upcoming videos, right? Okay. So let us check if I have the polynomial p of x, which is equal to x plus 2. I have to check whether x is equal to 2 and minus 2. Are they roots of p of x or not? How do I check? I'll substitute the value of x is equal to 2 here. So p of 2 will become what? 2 plus 2, which is equal to 4, not becoming a 0. So this is not the root. For x is equal to minus 2, p of minus 2 we have to find. So it is minus 2 plus of 2. This is becomes 0. So p x is equal to minus 2 is the root of the expression p of x. That's quite easy now. If I want to find what is the root of this equation, then simply I have to equate it with 0 and find the corresponding value of x. I can easily identify. I don't have to randomly put the values. I can easily equate it to 0 because by putting the value of x, I should get 0. So why not equate it to 0 and do the reverse engineering to find the value of x? So we can find the value of x like this also, or the roots of the value or roots of the polynomial p of x. Right, guys? So this is all about the basic understanding of algebraic expression, and we have also understood what are polynomials, and we have understood the most important thing for this video, which is root of the polynomial, right? In the next video, we'll be understanding the remainder theorem and factor theorem for polynomials.